Alright, in this lesson we will continue to practice analyzing functions and their graphs. We're talking about domain and range, end behavior, evaluating using the graph, x and y intercepts, maximums and minimums, and increasing and decreasing intervals today. Alright, let's start off with the domain. The domain is the x values of a graph. So we ask ourselves, how far to the left does it go and how far to the right does it go? We're supposed to assume that this keeps on going, so this goes to the left forever and this goes to the right forever. That's why the domain is going to be negative infinity to positive infinity. Now the range is the y values. So we ask ourselves, how low does it go and how high does it go? Well, this is how low it goes right here. So the bottom is -4. So we're going to start off with our -4. Now how high does it go? Well, it goes up forever. So it's going to go from -4 to infinity. Alright, now infinity always gets a round parenthesis. Okay, but this graph touches -4. So -4 is included as part of the function. So we will put a square bracket to show that -4 is included. Now, end behavior. End behavior is all about what's happening on the ends. In other words, what's happening on the left part of the graph and what's happening on the right end of the graph. Okay? And basically, for most graphs, we're talking about, is it rising or falling? So for this graph, on the left side, on the end, is it rising or falling? Well, you see on the left, it's rising. Okay? So we know that on the left, it's rising. Okay, what about on the right? What's happening here on the right? On the right, it's also rising. Okay, now how do we show that? If it's rising, I want you to think positive infinity. If it were falling, then it would be negative infinity. Okay, so now here's how end behavior works. Basically, we're saying as we go to the left, it rises. Okay, that's what it would be sort of in words. As you go left, the function rises. And in this case, then we say for the other end, as you go right, the function rises. Okay, in words, that's the concept of end behavior. What happens as you go left? Oh, it rises. What happens as you go to the right? The function rises. But there's an official mathematical symbol system that we use instead of these English words. Okay, and here it is. To capture the idea of as we go to the left, what we say is, as x approaches negative infinity. Okay? So this is a mathematical way of saying as you go to the left. We say as x approaches negative infinity. By the way, that's how you read this. You put an arrow, but this would be read approaches. Now we want to say the function rises. So we can say f of x approaches positive infinity. Okay, because that says the function rises. The function approaches infinity is a mathematical way of saying that. Okay, so similarly, a mathematical way of saying as you go to the right is you can say as x approaches positive infinity. Okay, because I mean this is the x-axis right here. So as the x values approach positive infinity, okay, I mean you could think of this as being positive infinity over here. So if the x values are approaching positive infinity, you're going to the right. All right, so that's why if I want to say as you go right, we can say as the x values approach positive infinity. And again, the function rises, so we can say the function f of x approaches positive infinity. Okay, so the red is what we will actually write for our end behavior. Okay, and if we had a graph that fell, we would just put negative infinity. So let's go ahead and put it where it goes. So we said as x approaches negative infinity, all right, meaning on the left, f of x approaches positive infinity, meaning it rises. Okay, as x approaches positive infinity, in other words, as you go to the right, f of x approaches positive infinity. Again, it rises. So basically, rises, rises. Now look, anytime you do end behavior, I want you to understand everything here in red is always the same. This part never changes. So as soon as you get ready to do an end behavior problem, the first thing I want you to do is write all this out. As x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. The only thing that's going to change is this last piece on the end. And if, in this case, if it rises, we will say, okay, it approaches positive infinity. If it falls, it will be negative infinity. But for this problem, it rises on the left and it rises on the right. But everything in red stays the same for all end behavior problems. Okay, I know that was a long explanation, but let's move on. For number 4, we need to evaluate the function at 2. Now remember, this is the format when we will have f of x equals some value y. But whatever's inside the parentheses, that's x. And then whatever you get that goes with it, that's the y value. So when I look at this number right here, f of 2, please understand that this is an x value. That means we must be looking for the y value that goes with it. So let's go to an x value of 2 and look around. Okay, so here's an x value of 2 right here. Well, at an x value of 2, the function is right on the line here. So this is the point 2 comma 0. So at an x value of 2, the y value is 0. Okay, so f at 2 equals 0. In other words, we've got the point 2 comma 0. All right, what about the value of f of negative 4? Okay, so let's go to negative 4 and look around. So here's an x value of negative 4. Now if we look down, then here's the function, okay? So this is the point negative 4 comma, and I'm looking across to see how low this is. So this is the point negative 4 comma negative 2. All right, so that means at an x value of negative 4, we're at a y value of negative 2. So we have our x and our y. So looking back at this, remember, this is our x value, and that means they must be asking us for a y value. And we just found out that at an x value of negative 4, the y value was negative 2. Or you could write that as an ordered pair, negative 4 comma negative 2. Okay? Now, this time it's backwards. For what x values does f of x equal negative 2? Well, again, remember the format. The format is f of x equals y. So this time they're giving us the y value, and we need to find the x value that goes with it. Okay, so they're giving us the y value, and they're asking us for the x value that goes with it. So let's go to a y value of -2 and look around. Okay, let me just erase some of this stuff. Okay, so a y value of -2. All right, so here's a y value of -2 right here. Well, and the function is right on the line. So at a y value of -2, you know, this is the point 0, -2. So the x value is 0 at this y value of -2. Okay, so the x value is 0. Okay, so one x value is 0 because we have 0, -2. Are there any others? Yeah, if we look further, okay, if we look over here, there's another x value at this y value of -2. There's another x value at this height. This is the point -4, -2, because you see we're over here at -4. Okay, so that's another x value that goes with this y value of -2. Okay, so we also have -4, -2. So if you were just saying the x values, you would say 0 and -4. All right, these are the x values that match up with a y value of -2. Okay, so when you're dealing with y values, basically you can just draw a horizontal line and look for the places where that horizontal line hits the graph. Okay, the x-intercepts, or zeros, of the function. All right, well, the x-intercepts, or zeros, are these places where the graph touches the x-axis. So this is -6, 0, and this one is 2, 0. So those are the x-intercepts. Also known as zeros. Now, what about the y-intercepts? Okay, well, the y-intercept is where the graph touches the y-axis. And so this is the y-intercept right here. The y-intercept is 0, -2. All right, now let's talk about the maximum and the minimum. All right, the maximum, and this is sometimes known as the absolute maximum. So I think I'll just put that in parentheses. All right, if I say absolute maximum or if I just say maximum, either way I'm talking about the highest point on the entire graph. Okay, but the thing is, this graph goes up forever. So there is no highest point. It just keeps going. So there is no maximum. Okay? So we'll just put none. There is no maximum. There's no absolute maximum. However, there is something called a local maximum or local minimum. In fact, okay, now we are ready to talk about increasing intervals and decreasing intervals. So let's take a look and see what's going on. So look, imagine that you are a small creature and you're walking along this path like it's a mountain trail and you're hiking. And we're trying to go from left to right. So we're trying to get from point A to point B. Okay? Now, for the first part of the journey, you're going downhill like this. Downhill, 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 downhill. Okay? But then you change directions. And then all of a sudden you're going uphill, like this. Okay? So the downhill part of the journey is going to be decreasing, and the uphill part of the journey is going to be increasing. All right? Now, remembering that this graph goes forever as it continues on this way, and as it goes the other way, also it goes forever. But for these intervals, what we need the domain, all right? We need the x values that go with this. So looking at the, let's see. So first we want, for number 11, we're working on the increasing interval. So that means we should be looking at the green part of the graph. Okay? So give me the domain of this. Give me the x values. All right? Hopefully you can see that this green part of the graph, it starts here, but don't say -4. You need to look at the x value. So it starts here at -2, and it goes to the right, like that. Okay? That's the domain. This yellow I just drew indicates the domain of the increasing part of the graph. So the graph increases from -2 to infinity. All right, x values. So write that down. So the increasing interval is from -2 to infinity. All right, and we'll use a round parenthesis because right at -2, it's neither increasing nor decreasing. It's right in the middle. Okay, now how about decreasing? Now this red indicates the decreasing part of the graph because it was downhill from left to right. But again, we want the x values. When I ask you for the interval of decreasing, I'm talking about the x values. So hopefully you can see that the cutoff is right here again at -2. All right, and this graph is decreasing everywhere you are to the left. So basically the domain of this red arrow is -infinity to -2. Okay, so that was the decreasing interval, is from -infinity to -2.